about your trajectory and your role at Magic Leap.
Yeah, hi everybody. I'm very pleased to be here in our inaugural webinar. So I'm one of the originals at Magic Leap. I've been doing this for quite a number of years. I did 11 years at NASA before I came to Magic Leap, working on a distribution of things, some of them in the GIS sector with geospatial data visualization, and working on sensing systems for rockets and space station parts. And since I've been at Magic Leap, I've been doing systems engineering, and now I'm responsible for our product strategy and how we approach making a platform that folks like Jonathan Reeves will be talking to you about, AR Visio, in service of applications like what Jonathan Chow is going to talk about at Golder. So I'm really delighted to be here. We're going to have a fun time talking about spatial computing and how it's real-world applications.
Thank you, Sam. And we also have Jonathan Reeves, founder and CEO of Visio. He's joining us from the UK. Jonathan, can you tell us a little bit more about your background?
Yes, thank you, Kathy, and hello, everybody. Nice to meet you here today. As mentioned, I'm Jonathan Reeves, founder and CEO of Visio. By way of background, I'm fortunate to have founded a number of successful ventures over the years, a number in telecommunications, networking, and cloud computing spaces. But today, I'm pleased to be here to discuss our Visio, a very exciting company working with augmented reality and spatial computing for industrial use cases.
Fantastic. Thank you, Jonathan. And also we have Jonathan Chow, geological engineer at Golder. He's joining us from Vancouver. Jonathan, can you share a little bit about your background?
Yeah. Hi, everybody. I'm a geological engineer at Golder Associates, basically focusing a lot in the mining industry. Today we're just going to give you a little bit of insight about what our company does and how we've been using spatial computing in our industry.
Fantastic. Thank you so much. Now I'm going to hand it over to my colleague, Sam Miller, who's going to start us off. Sam?
Okay, cool. So I'm going to give you a quick intro on some Magic Leap pieces of the puzzle. So if you want to go to the next slide. Next. What we're doing here at Magic Leap is we're a tech company. We started in 2012. We have a large collection of technologies that we had to cram into a very small space with the Magic Leap 1 headset. Took us about 8 years to this point, 1,600 employees. We've got a very large patent portfolio in the space of augmented and mixed reality computing. And we're actually international, so 15 sites around the world, and we've got some pretty big strategic partners who are helping us on this journey because they really see spatial computing as that next generation of the way that humans interact with digital information, kind of like the PC revolution and the smartphone revolution. Next. So when we talk about what our vision is, really when we talk about what is the next generation of computing, we're thinking about it as freeing people from the limitations of where digital media exists today. Right now, they exist on the 2D glowing rectangles in our pockets, on our desks, on our walls with our TVs. So how do we re-engage with the world and digital media? So it's about interacting with us, with other people, with the environment, and with digital content that can exist with us. You want to go to the next one. So when we talk about our mission, we're merging the physical with the digital. Right now, digital has to live in specialized appliances. We're trying to put digital information into the world so we can interact with it. So the next thing is, if we want to talk about spatial computing, the way we define spatial computing, I think it's good to put it in contrast to the other kinds of XR technologies, if you will. So we're all familiar with virtual reality. Virtual reality has a place. It's very valuable for some use cases, but fundamentally what it's doing is it's separating us from the physical world, and it's taking us to another place. So if your application requires you to go to another place, virtual reality is a great tool for that. When we think about augmented reality is mostly today, it's what happens on your phone. You're holding up your phone, you're taking a video, you're overlaying digital content. So that class of use cases is ubiquitous. This is the everywhere, everybody, all the time computing device that's available to us. And so you can see augmentations in the world. We have some platform offerings that allow that. But the real focus is on spatial computing. How do we let digital content interact with our environment, be in our environment, and even persist in our environment even if we're not looking at it? That's the way that we think about spatial computing. And so the rest of this talk is going to be about how do we make that tangible for this particular industry vertical that we're talking about. Go to the next. So as we've been developing a platform, working with partners, what we started to see is there are 4 major categories for spatial computing that have kind of percolated up to the top in our travels with customers, with vendors, with partners who are making solutions. And so I just want to highlight them here so that we can look at the breadth of the space. So the first macro level use case or focus area, I would call it communication, collaboration, and co-presence. So right now, particularly in this COVID-19 environment where we're all sitting at our homes and offices or backyards or wherever we are, how do we connect in a more connected world? The opportunities for spatial computing is to draw us closer together and to give us a more connected way of communicating and collaborating. And so put a couple logos there of companies that are making collaboration solutions on top of the Magic Leap platform. Of course, the focus of what we're talking about today is spatial visualization. So how do you make a better informed decision when you can actually see information, walk around it, touch it, point at it with another person who's standing right next to you, even if they're on another continent? That's going to be the topic of today's discussion in the particular context of a mining industry, but it's generally applicable to AEC and CAD and visualization of furniture and houses for pre-staging environments. There's a lot of different solutions there that people are making in the spatial visualization of data to drive better informed decisions. Then another major category is learning and assistance. So how do you improve the efficiency, the time to competency for skills? How do you improve the efficiency of the operation? How do you have a subject matter expert who's on another continent help a technician who is working on a complex piece of machinery or a surgeon who needs additional insight? That's kind of what we think about as the learning and assist category. And then finally, when we talk about location-based experiences, a lot of times we are finding these use cases where people want to experience something at a location where they come and there's a device there that allows them to access and interact with digital media, whether it's like in a retail context, like looking at different models of a shoe that you have lots of different digital models on a wall, or fashion shows where we're wearing devices and you're seeing different kinds of clothing. So that's a broad categorization. Let's go focus on the spatial visualization category. So what we're going to, the industry challenges here that we believe are addressed with spatial visualization is, if you think about it in the AEC space in the pre-construction, how do you visualize what you're going to build before you build it? And that's useful both for the engineering teams, but it's also useful for the customers so that they can have a visual image of what it is that they're about to see. The next one is in design reviews. Right now, if you want to do cycling of your design, if you have to print it out or make a model of it, you can, to have that tangible experience of multiple people looking at a particular artifact, you could do that by putting on a headset and seeing it digitally. Reduces your iteration cycle time dramatically. And then the last one would be customer engagement. When you're talking about how do you show what the end state of an experience, the experience of standing in the lobby of that new building, or as we're about to see, what does it look like the mine that you're digging underground that's going to take you a long time to construct? Those are basically the ways that we think about spatial visualization and the problems that we can solve when we're using a mixed reality computing device. So with that, let's turn it over to Jonathan Reeves, who's built a solution for the space. Over to you, Jonathan.
Thank you, Sam. Yes, as Sam mentioned, our Visio has been working with Magic Leap, and I'm very pleased to say that we have partnered with Magic Leap and now are working together on a number of customer scenarios and use cases. And I must say, from my perspective, it's very exciting to bring together the software solution that our Visio builds and brings with the hardware and overall platform capabilities of the Magic Leap. And today we have the good fortune of having Golder, who are a customer of ours and Magic Leap, talking about the solution. So we're very excited to bring that all together here today in one place. I think we'll sort of move right along, Kathy. I wanted to begin by talking about some of the challenges and opportunities that are associated with spatial computing, and in particular, when working with industrial scale models. 3D models, of course, are the mainstay of many activities, ranging from BIM type programs, Revit and so forth, that are used during the architectural engineering and pre-construction phases. There are tools like Navisworks that are used when bringing together the various layers during the process. And there are tools like LiDAR and photogrammetry that are used to capture reality and bring reality into the experience. There are some common characteristics with each of these types of data. And one of them is they're extremely large and extremely complex. So for example, a Revit or Navisworks model can easily be tens of millions of polygons, even hundreds of millions of polygons. The polygon is, at the end of the day, the sort of the raw element of a 3D model, and the number of polygons affects the type of rendering and the type of devices that you can render upon. LiDAR scans, on the other hand, may have billions of points. If you're capturing a large area, this can be extremely complex data and, again, difficult to visualize. So the problem we saw was that the industry is using these types of 3D capture tools and CAD tools today, but the devices themselves are not able to render that degree of complexity. So a typical XR device might render 1 to 2 million polygons. So you can see there's an order of magnitude challenge there. So our Visio set about building a solution to that problem. So the Visio toolset, which we'll get into in some detail here, allows you to bring in the models from the different types of 3D data sources, allows you to then work with that data, and then allows you to share that data in a mixed spatial computing environment. This can be at one location, or as you'll see from some of the scenarios, can be across distance, allowing users to participate in the session at multiple locations simultaneously. So moving on to take a look at what that might appear like, here's an example. In this case here, we have several participants in a location that are reviewing a 3D model. The model has been ingested into the Visio XR system and then shared amongst multiple participants. One of the nice things about spatial computing is the model can appear in common space and be synchronized. So what do I mean by that? Well, in virtual reality, it tends to be a very sort of isolated individual experience. So each participant in a session would wear their virtual reality headset and they see their world. They may see an avatar representing others, but it's somewhat isolated and it's cut off from the real world itself. In spatial computing, you can synchronize the environment so that all participants see the same model in the same space. So in the example shown in the picture, we can see two participants that are reviewing the model locally. On the right-hand side of the diagram, we have a remote participant who is seeing the same thing, but at another location. As changes are made by one of the participants, it's then synchronized amongst all. So what we have is a real-time meeting environment. In that meeting environment, you can annotate the model, you can highlight portions of the model that are of interest, you can clip portions of the model and so forth. So you have a whole experience that allows you to see that content in that shared environment. Last but not least, there's also audio communications. So of course you can talk through the experience with the remote participants. They can join in and so forth, and bring documents and other pictures, images, and so forth into the experience. So basically, the 3D model forms the heart of the collaborative activity, but then you augment the model with a number of different additional types of data. Thank you, Kathy. So changing gears a little, let's talk a little bit about the architecture of the platform, because at the end of the day, there's an app, of course, that runs on the immersive device, and the app we have for Magic Leap is called the Visio Immerse app. It's available on the Magic Leap World Store. And this is where the visualization experience occurs and provides the real-time collaboration tool, the front end, as it were. The back end is where quite a lot of the heavy lifting takes place. So in addition, we have a tool called XR Director, which allows you to bring in 3D content, to optimize the 3D content to make it suitable for consumption, and then provide other features and functions, which I'll detail in the next few minutes. There are also versions of the Immerse app available for mobile devices. So it's quite common in our customers to have a set of spatial computing headsets, and perhaps some other participants that are using an iPhone or an Android phone or tablet to join the experience, and they also can be synchronized, so they are consuming the same 3D content at the same time. there's a very important concept associated with the handling of large-scale models that I'd just like to touch on here. And of course, we can follow up in some of the Q&A if more information is of interest. But that is what a technique we call hybrid rendering. So what we do with hybrid rendering is we use the local GPU, CPU power of the spatial computer to render a version of the model, to place the model in the real space and so forth, and control the collaborative experience. But then when looking at very high level detailed portions of the model, we are able to stream content from XR Director using the CPU and GPU sources of the Director server to actually stream the experience in much higher resolution into the headset. So this combination of local rendering and remote rendering and the tying together of those two experiences is what we call hybrid rendering, and that's part of the Visio experience. Kathy? So taking a look at the Director itself before handing over to Jonathan from Golder, just to touch on a few of the key features and functions of the Director. So like many applications of its type, it can run literally on a PC. We often run it on a laptop. We bring the laptop along with us to a customer's location. We can hook up several headsets and devices over Wi-Fi, and we're off and running. In other cases, this might be more of a permanent installation, in which case you would deploy the Director on an edge computing instance, or indeed run it from the cloud. So we try to ensure the product and platform has a scalable deployment model, which allows you to use it in different scenarios. On the Director tool, there's a number of key functions that are provided. One is the ability, of course, to import and optimize 3D models. We support over 30 different 3D models and formats, ranging from LiDAR data types, different CAD formats, BIM formats, and so forth. We also tie in with BIM 360, which is an Autodesk tool that is used a lot in the industry as a central repository for designs and information. The models can be brought into the Director, and then they can be aligned. So often you might have more than one model that you wish to include in a scene. An example might be where you have a LiDAR scan, and then you wish to overlay CAD on top of the LiDAR to see how it will appear in the real world. Another example is where you might have multiple models and you wish to align them side by side so you can do a comparison between those models. All of that feature and functionality is built into the Director and allows you to assemble a scene without any programming, all done through the graphical user interface. On the right-hand side of the diagram, you'll see the user session panel and a QR code. Well, the QR code can be emailed or messaged to any participant in the meeting. They simply hold the QR code in front of their headset, and then the Magic Leap device will connect to the session, and now you're joined in the collaborative experience. So our goal was to make this as user-friendly as we possibly could, to create a platform and a tool that did not require any coding or development, but literally could be used by end users across a whole variety of scenarios. So with that, I'll hand over to Jonathan Chow from Golder.
Great, thanks, Jonathan. So I figured it would be best to kind of give a framework of who Golder is, so we can kind of dive into how we actually use this in spatial computing. So in general, who is Golder and what do we do? Well, in short, we're an employee-owned global organization providing consulting, design, and construction services in the service areas of the earth, the environment, and energy. Golder started in about 1960 in Toronto, Canada. And since we've grown to globally over 7,500 employees, 165 offices in over 40 different countries. Kathy, you can go to the next one, please. So we're involved in mining, oil and gas, manufacturing, power, government, transportation industries, focusing on services including environmental, ground engineering, tunneling, pipelines, remediation, regulatory compliance, design, construction support, waste and water. So as you can see, we are quite broad in the services that we actually do provide. Next slide, please, Kathy. So a bit about myself. I'm a graduate from the University of British Columbia's Geological Engineering program. I've been with Golder for the last 10 years. Specifically, I sit in Golder's Mine Stability group in Vancouver. In this group, our primary focus is on rock mechanics for both open pit and underground mining projects around the world. And that goes all the way from an exploration of a site through the operation, as well as the closure of those sites in the end. So my daily work does typically involve a lot of 3D spatial data, including using programs such as AutoCAD, various mine design software packages from MineSite, Surpac, Vulkan, Deswick, a lot of photogrammetry models, a lot of survey-generated point clouds. So many of the file formats that blend very well into the ArVisio platform. Next slide, please. So where does spatial computing fit in consulting? Well, problems are getting increasingly complex, and it's even becoming more important for our clients and their stakeholders that everybody is on the same page. We wanted to find a solution to best communicate our designs and concepts. In doing so, we also wanted to make sure that we had a solution that would be compatible with what we typically do on a daily basis. So not trying to reinvent the wheel, trying to use something that would be kind of convert natively. So when we started this journey into exploring options for spatial computing, we had a few key goals. One, we wanted to find a way to rapidly showcase our designs and concepts in a new and engaging way. And we also wanted to find a solution that would be compatible with our typical design software packages. So back in 2018, this led us to looking into some different headsets, and we ended up getting a couple of the Magic Leap headsets just to see how this technology could be used and how easy things were to control, how the visual quality was, and I think overall we were extremely happy with the results from that. In 2019, we stumbled upon ArVisio's software, and we got some discussions rolling with them. And in fall 2019 last year, we started actually using the ArVisio platform to showcase extremely detailed designs for complex engineering problems and designs. Next slide, please, Kathy. So one of the main benefits we found using spatial computing and the ArVisio platform is the ability to quickly load our design files with little to no additional processing time. These files include files generated in AutoCAD, the mine design software packages, photogrammetry, LiDAR surveys. Some of these files are extremely large, but in the ArVisio software, there's actually built-in tools to optimize specific files so they render properly for the Magic Leap headset. The ability to have multiple users viewing the same model at the same time has been an incredibly valuable experience when initiating discussions around designs. Being able to see the world around you as well as the designs actually allows for very efficient collaboration. You're not just looking at one person's looking at one thing, one person's looking at the other. You can actually see what the other person's looking at, point to the exact same thing, and have a discussion. That's been incredibly valuable. So at Golder, we've used spatial computing to showcase complex designs and our ideas to our clients and their stakeholders. Like I said, we found this an extremely efficient way for them to understand what we're working on. For us as engineers, we're very used to looking at these 3D models on a computer screen or in a 2D figure, and we can make sense of that. For other people, it might not be so apparent, right? So spatial computing really takes away a lot of that uncertainty of simply kind of staring at a model on a computer screen or looking at those two-dimensional figures. Suddenly, when people put on a headset and actually use spatial computing, they understand the larger problem. They understand the model. They understand the layout of everything. So we've actually started to use spatial computing for things like kickoff meetings. We've found it's an effective way to get new project team members a better understanding of a layout of a site, engage them in health and safety discussions, identify potential hazards, logistical challenges of a site before even stepping foot on the ground. So yeah, it's been extremely valuable for that type of communication. Kathy, next slide.
All right, well, thank you so much to the three speakers for their insight sharing, the work they're doing in spatial computing. Now we're going to start the moderator-led Q&A, where I'm going to be asking some questions to our speakers, putting them in the hot seat, to say. The first one I want to start with is a question for Jonathan Reeves. With so many CAD and BIM programs and reality capture devices, how many spatial data formats can our Visio process?
Okay, Kathy, thank you. It's a great question, and it's quite a long answer, but I'll give the short one. Obviously there are many different 3D formats, and what the world doesn't need is any more, but unfortunately we do seem to come up with more as an industry. So it's a bit of a challenge, and therein lies an opportunity. Really, the types of spatial data that we can ingest fall into several key groups. There's point cloud data, which would be typically produced by LiDAR scanners or photogrammetry or similar types of tools. So a point cloud is basically, you use a scanner, you capture the area around you, and for each point that the laser hits, you get back an intensity reading. Often you overlay with a photograph that gives you a color. So basically you end up with a sea of points, which can be billions of points that have color and intensity reading. So to take that in and then turn that into something you can visualize in the Magic Leap headsets is part of the magic and part of the trick we do. The second type of data we see a lot of is BIM and CAD data. So I've mentioned we integrate with Revit and Navisworks. We have a plugin for Revit, a plugin for Navisworks that allows us to bring in not just the 3D geometry, but also all of the metadata associated with the model. Things like dimensions or vendor codes, this type of information is particularly relevant in the AEC industry. So that data comes in, and that's all made available as part of the spatial computing experience. We also offer, as I think I mentioned before, a connection with Autodesk BIM 360 and Fusion 360 cloud services to any model data that's stored in there, which can be up to 50 or so formats, can be converted into a common format and ingested into the Visio platform. And then last but not least, we offer a number of sort of common 3D mesh formats. So things like OBJ, FBX, STL, GLTF, and then a few vendor-specific ones like DWG and DGN. So giving you a little bit of a flavor, but at the end of the day, usually we can get the data in one of those formats. Occasionally we come across a situation where a customer has a specific format that we don't currently support. In those cases, we're usually able to bring that format in within a few weeks of work. So it's not a showstopper. It's an ever-growing list of formats that we support.
Thank you. Thanks. That's a great answer. A lot of information. Thank you, Jonathan. Now I have a question for Jonathan Chow. Jonathan, what are some of the first steps a business can take to start implementing spatial computing? What advice would you give folks here at the webinar?
I think, similar to what I mentioned in the earlier slides was we started out with kind of a brainstorming session, looking at what tools were available and seeing how that could be utilized for your specific case. You need to kind of come in with a clear idea of what you actually want to accomplish and what you want to communicate. Having a good understanding of what, the tool can do and what it can't do, and then trying to leverage it to accomplish your goals. It can be often difficult to embrace new technology, but I think you look at all the different things that you can visualize and the way that it can communicate. You just kind of have to come up with a list and then go from there. Then start having those discussions. We've had a very good dialogue with our Visio and to see where we can kind of take this in the future. So.
Thank you so much. And now, Sam, this one's for you, and I know that you want the other speakers to chime in, but what are some of the benefits of using spatial computing in the AEC and industrial sectors?
Yeah, no, that's a great question. I think we were kind of highlighting a little bit of that earlier on, is being able to pre-visualize things, reduce the cycle times of design for marketing and sales when you're showing new products. We're seeing that it's definitely in the AEC space, and I'll let Jonathan dig into that a little bit more since he's got a lot of customers for AR Visio who are using it to solve a lot of their problems. But we're also seeing those same classes of use cases in other industry sectors. being able to do design reviews with people who are local, being able to do them with people who are maybe scattered around the globe, but you still want that tangible experience of standing over a model, even if it's a digital model, but it has the sense of presence of a physical model. Being able to do those shorter cycle design iterations and communicate better about what you're looking at. I mean, we had an example with a large architecture firm in Texas where they went into the inside of a warehouse, and instead of building out an actual building, they actually just implemented it digitally, and then they were able to walk through it at one-to-one scale. So it's classes of things like that where you're getting the early use cases are about seeing things and then interacting with them. And I think what that turns into over time as the vendors produce tools on spatial computing devices is you start to be able to manipulate those models. But Jonathan, maybe you have some more resolution there.
Yes, and there's some great examples there, Sam. And I think you mentioned the ability to walk through at life size, and I think that's a really important aspect of this. So in the examples we showed in the slides, we were looking more at sort of tabletop scenarios. But at a moment's notice, any one of those users or all users can select to go walkthrough mode, and walkthrough mode will then take the model, whatever it may be, and produce it in life size. So you suddenly sort of have the life size model around you. You can then, using the Magic Leap controller, you can then teleport around inside the model, which is one mode of operation. But where I find it the most powerful actually is you can walk through the model. So you can take yourself to a navigation point of interest, and then several of you can literally walk around that space and sort of interact as if it's really there. While doing that, you have audio communications, as I mentioned. Now, if you happen to be in the same location, then you don't need audio because you can hear each other. So we have this concept of multiple spaces. A space is basically a location where participants collect. So space A, you might have 2 or 3 participants. They don't need audio bridging because they're all in the same location. Space B, you may have another group of participants that are also part of the experience, but they need the audio bridging with space A because, of course, they're in a different location. So when you establish a session, you can select multiple space mode. You can yourselves select which space you are in, and then the audio bridging figures all that out and connects you. So there's a lot of subtleties that go into making the experience as seamless as possible. And of course, at the end of the day, we get a lot of feedback from our customers, which is what we love to do in terms of what they would like to see in terms of for the experience to take it to the next level.
And that one-to-one scale thing, it's incredibly valuable. A colleague of mine, we were showing some models off at an internal conference Golder hosted, and we're actually able to load in a model of a tunnel. In the same, within a couple hours, we were able to pull in this model that we received on site and generate this. And we actually showed this tunnel model in a large atrium space. And this was, say a 5 meter by 5 meter tunnel. And it filled up the entire atrium. And when people put on the Magic Leap headset, it's this kind of moment where people get blown away, and they're like, I can't believe I'm looking at this. And then you can really people just get lost in that world and start discussing like they never would by looking at photos. So, yeah.
And I could add a little bit of actual extra flavor there. When I was at NASA, I worked on I was in the general thing of getting better insights out of just seeing something at scale. I worked on a rocket, and it was like maybe 40 feet tall and about 18 feet in diameter. And there were some more junior engineers on the program, and they had made some pieces of the rocket that on their CAD model screen, they were just flipping them around. They were little piece parts, and they sent them down to the machine shop. And this is super common, I find, in a lot of different industries. A new engineer just out of school made the thing, sent it to the machine shop. But what he sent over to the machine shop was something that was it was huge, like the size almost of a person. And he spec'd it to be made out of CNC machined stainless steel. And you went down to the shop, and the guys were just really upset that somebody would first off send them something that big that tied up their most important machine. And then he had spec'd in carving out holes in the middle of it, that there was no 5-axis machine that could make a 90-degree turn inside a billet piece of steel that was like, the size of a person. So what we've been doing, we've done some visualizations of other classes of, CAD models where you don't realize exactly what the scale is until you put it 1-to-1 and you stand right next to it. And it immediately gets you, it doesn't pass the look right test. You look at that thing and it's like, oh, I expect that thing to be made out of aircraft grade stainless steel and I'm sending it to the shop. Okay, let me think about that again. So I think that's another example that is from a different industry, but it's the same class of problem you're solving. Is you're getting an intuition about looking at something in a more realistic fashion that's more tying the digital model that you have to the physical world in which it's going to exist.
Or you realize you screwed up your units.
Yeah. Yes.
Then you have a real problem then. I want to move on. Go ahead.
Sorry, I was just thinking that example that Sam gave. I can imagine if that poor engineer went down the next day and said, "Oh, I didn't mean it. I need to make a change."
Exactly.
Okay. Now I want to kind of talk a little bit about education. So we know that someone can begin building the skills that say they need to have a successful career at Golder or similar firm. They can start as early as high school. What do you see as the role of spatial computing in the education domain with respect to AEC?
Yeah, I think that's a really great question. Yeah, go ahead, Jonathan. You start.
Sam, do you want to go first? Please do.
Okay. When I was in high school and college, I was blessed to be exposed to some AEC CAD packages, and my father's in construction. So, I saw him building things and trying to make that digital to transition from, draftsman into drawing things in AutoCAD and stuff. And AEC in particular is a pretty slow-moving industry, and one of the big opportunities that I think I see is when you're exposing students in STEM education early on to a broad diversity of tools. I think it's a very powerful vector for change in an industry, because there's a lot of cross-coupling in different industries right now where you're using different tools to solve old problems, technology tools to solve this. So I think exposing students early on to different kinds of technology, it's going to have a knock-on effect as they go into the workforce and they expect to have those tools available. They don't expect to just see their CAD models on a screen. They expect to manipulate them and interact with them by walking around them, as Jonathan Reeves was saying. I think there's a lot of different factors here, but to me that seems like a pretty important one, is just getting exposure. It's a different set of tools that you're bringing into your career. Jonathan?
Yes, thank you, Sam. Yes, and I think it's not just for AEC, right? So AEC is obviously an area we spend a lot of time with, but there are other industries as well where you're using traditional CAD tools, and AutoCAD is one we work a lot with, as well as indeed others, not surprisingly. And in education, and a number of the technical schools now have, I was surprised actually visiting some of them, just how many CAD stations they have, the breadth of the training and the curriculum that they put together. And in many situations, what they're doing is they're taking the output from the CAD and then using 3D printing tools and other techniques to turn that design into reality. And they were particularly excited about the idea of being able to do a quick turn, as it were, in using spatial computing, so that you don't actually have to go to 3D print it until you're ready. You can take a quick look in the spatial computing environment. You can interact with others as if the items and elements were really there. And then when you're ready to commit to the hard format, as it were, push the button and print. So we're seeing a lot of interest from technical colleges and schools, even some of the high schools that have advanced STEM programs, where they can use this kind of technology to expose the students much earlier in their careers, as it were, to these kinds of techniques.
And just to add on to that.
Oh, go ahead, Jonathan.
Just to add on to the education basis. I mean, never did I ever imagine that we would be using spatial computing. I mean, my education, the reason why I bring it up in the presentation is that I'm a geological engineer. We look at rocks. Rocks and spatial computing, I don't necessarily think that people would associate the two together. But the world is getting so much more complex. Our problems are getting so much more intricate. So we need to be leveraging tools like spatial computing to really communicate those things. We see so many more people now, even in our industry, getting into coding, getting into numerical modeling. These things are there's no one silo anymore. Everything is very interconnected. So
thank you, Jonathan. So now we're at the 41-minute mark. Guys, so we're going to move into, this is such a good conversation. We're going to move into the attendee Q&A. And for the attendees out there, you guys have been sending us lots and lots of questions. I don't think we're going to be able to get to all of these, but that we will be sharing emails at the end of the presentation, and we will try to get some of these answers to you. It's a very engaged audience. So now I kind of want to start with some of the questions that have been posted. I'll start with this one. Since a lot of manufacturing sites need to be reorganized, fulfilling the COVID-related requirements while keeping productivity, how can we use ML1, Magic Leap 1, in our Visio software, imagining running a production site with digital twins available? So I don't know if Jonathan, who wants to answer this question?
Well, I'll take a first cut and then perhaps turn over to others. But yeah, the whole concept of digital twin is an exciting one, and it's I wouldn't say we've got it fully productized yet, but we do have a number of tools in the director that we find are extremely useful in these kinds of scenarios. I'll give an example. So we had a customer that wanted to bring live IoT data into the experience and basically annotate the 3D model with live IoT data from machinery and other data feeds, and then go to a walkthrough mode and actually sort of allow you to, as you're walking through the model, to actually see in real time IoT data that's being fed from the real equipment, from the twin. And so we built an interface that allows you to do that. It connects via a protocol called MQTT, which is widely used in the IoT data space. And this could be used to connect with things like the Azure IoT Hub, ThingWorks, or the Amazon equivalent. So you basically can collect all your IoT data in one of those cloud collectors and then bring that into the director and then have that appear as part of the 3D model experience. So as I said, I don't think it does require a little bit of customization because of the nature of the beast, but this is something we're seeing a lot more interest in.
That's great. Thank you. Thank you, Jonathan Reeves. Jonathan Chow, this is for you. It's a two-part question. What is the minimum scale of an operation that you consider could have access to these technologies considering the cost of implementation? And by when do you think the implementation of this will be generalized in the mining industry?
Scale is, overall for a mining site, I think that the cost is actually relatively low. The cost really comes into the data collection, and that's typically already being done. The models are already being generated, externally anyways. So the cost of that visualization is really relatively low. So I think that there's not pretty much any site could probably benefit from it, and be able to implement it quite easily. Sorry, what was the second part of that question?
The second part was, and by when do you think the implementation of this will be generalized in the mining industry?
That part is a little bit, it's a little bit more tricky. I think mining in general can be sometimes fast at adopting technology and also very slow at adopting technology. From the concept of looking at mine designs and such, I think that's a lot easier than saying on-site, using the spatial computing on-site, purely just from health and safety standpoints, and that I think there's a lot more that needs to be done on the back end to figure out how that will all kind of play together. But certainly on the office-based mine design modeling work, I think it's pretty much already there, and it could be implemented whenever people want to get the hardware and the software to do it.
Great, thank you. And we've already gone past our time, but we're going to do one more question. This is for you, Sam. What's the user's thought about wearing a device for a long duration of time? How comfortable are C-suite audiences when it comes to wearing a device? We face this situation a lot. Sam?
Oh, that's a great question. So first off, let's answer the comfort question, and then let's answer the social acceptability for a C-suite, because I think those are two very different questions. So comfort question, I think the first thing is we spent a lot of design cycles in ML1 doing two classes of comfort. One class of comfort was how do you look through a device that shows you digital content in the physical world without eye strain. So we spent a lot of engineering effort, and we went through many design cycles of hardware where we invented some technology, we patented it, and then we put it aside and we made another generation of technology, all in the pursuit of a comfortable to see through device, a comfortable to wear device that doesn't induce eye strain. So that's one aspect of comfort. The second one is we spent a lot of effort making it so that it's comfortable to wear on your head, so that we would offload the load so it's not resting all on your nose bridge. And also we didn't put the battery in the compute on your head. That was a very explicit choice. We put that on the power pack so that it would be comfortable to wear for long durations. So it's very comfortable to wear for long durations. It's probably, I would guess, based on my feedback that I've heard qualitatively, it's one of the most comfortable devices in the industry to wear. So that would be the answer to question number one. Not a problem to wear for a long time. It's very comfortable. Second question is acceptability for a C-suite audience. So one of my side gigs at Magic Leap is I do all our investor demos. So when those C-suite people come, and they come to Magic Leap to see something, or we go on the road to show them something, I'm frequently the guy who's helping with those actual demonstrations. What I would say is it's absolutely not an issue if you're providing value. If you're just walking up and saying, hey, put this on, I would say people are kind of like, meh. But if you're looking at it and you're saying, hey, I can show you your mine at full scale. I can show you the factory you're about to build and let you walk through it. I can show you the car that you're about to design. I can pull up a seat and let you sit in the car that you're about to turn in to manufacture. You're about to turn on your manufacturing line. So when you're talking about that kind of value, it's something you can't really do on any other platform. When you add in, it's not just about seeing, it's about interacting. When you have a high fidelity control, a tool you can hold in your hand, plus you can manipulate it with your hands or talk to it or look at it with your eyes. Plus, when you have a platform that can persist that content in the same place across multiple users across time, I think when you're providing that kind of disparate value for so many use cases, it is not an issue at all for C-suite executives to wear it, because you're providing something that you just can't access in any other way.
Well, thank you so much, Sam. We're nearing the end of our webinar here. We went a couple minutes over, but we appreciate everyone's time in joining us. As you see in your screen right now, you have some emails if you want to get in contact with Magic Leap or Visio or Golder. These are the emails you can use to get a hold of some folks and ask some of your questions. We want to thank all the attendees that joined us live for the webinar and everyone that's going to watch this on the replay. Thank you so much for joining us. I especially want to thank all the speakers who shared their insight. Thank you, Sam, Jonathan, and Jonathan, for sharing your insight and letting us know a little bit more about what you're doing in spatial computing. That's pretty much a wrap for today's webinar, and we want to thank everyone for joining us.
Thank you so much.
Thank you very much.
Thank you,
Much
guys.
appreciated.